Okay, so in this video, we're going to do from numbers 4, 5, and 6 for 16.1, which was September 1995, game 1. Let's start on number 4. It says, if X is added to class 3, each of the following is a pair of students who can be added to class 1, except. Okay, so what they want us to do is to put X into class 3, and then they, not S, X, and then they want to know who all could be added to class 1, which of the pairs cannot be added to class 1. So which of the pairs, if you were to add them to class 1, would create a problem? I think this is a question that actually has a similar theme to the last one, and for that reason I want to sort of hash out that theme ahead of time. Because look who we have left. Okay, we've taken, so far on our board, we've put in R, S, and X. So the people we would have left are T, V, W, Y, and Z. All right, so I'm going to write that here for 1 second. We have T, V, W, Y, and Z. Okay, so what we notice is that the same people that we were worrying about keeping separate in the last question, which were V and Z and W and Y, okay, like V and Z have to be kept separately and W and Y have to be kept separate, those same people are still in play. And we still have two groups in which to split them. So what we really know is that like we're going to have to put one of T or V in here, V or Z, because they can't be together, and then the other one's going to have to go here, right? Because I need to make sure that they don't go in the same group. I have a little bit of problem typing, but hopefully I will straighten this out. V and Z, okay? And then the same thing applies for W and Y, because they can't be together, so we need to split them. And since we only have two groups remaining, we need to make sure that we take one of these pairs in each group. And that means that the T can only go here. So the person who can never go in group 1 is T. So we look for a pair that involves T, and if we find it, that's our answer. And when we do look, we find it that it's E, right? So the issue that they wanted you to get at, and you could do it a little quicker by just using what you're learning throughout the game or what you may have thought of up front, but really I think we learned about this in the last question, if not before, is that T, in this case, cannot go in 1 because we need to leave enough room in 1 to put one of the V or Z and one of the Y or W, okay? Okay, so that question I think was pretty easy if we were paying attention, especially to the last question. So let's take that off the board and go to number 5. Okay, number 5 says, if T is added to class 3, which one of the following is a student who must be added to class 2? So you'll notice a pattern, right? What they keep doing is filling in class 3 and then asking us what happens. At least that's what they've done on the past couple questions. So let's see if we put class T here. Now they're saying which one of the following is a student who must be added to class 2. So let's see who again has to be added to class 2. Again, and I don't want to keep repeating myself, but they keep repeating the same pattern. We have to look at who's left, and we have to make sure that the people who cannot go together, if they're left, we make sure we split them up, because there's only two groups left. So they got to reserve a spot. We have to reserve a spot, one in each group, for people who can't be together, like W and Y. So like one of them is going to go there, but then the other one is going to have to go here. All right, and then the same thing with the V and the Z. And then we just have to look at who's left, and they're going to have to go in class 2, so it's going to be X. Okay, so hopefully X is one of the answers, and it is. If we look, it's D. So this is where you're getting paid off for basically applying the same principle over and over and over again. And that doesn't always happen. Sometimes questions will use different principles, and you'll have to come at them from different angles. But it does happen often enough that when it does happen, you need to realize it and pick up on it quickly, execute quicker, because they're just going back to the same principle, and hopefully that'll get you through the game quickly and leave you more time for other games. Let's do number 6. So number 6 says which one of the following must be true, and they don't give us any extra information, so we're supposed to just go through the answer choices and figure out which one has to be true. You'll also notice when you look at the answer choices that they're all conditional answers. They're all saying if this, then this. So the right one is obviously one where the sufficient condition is going to guarantee the truth of the necessary condition. Wrong answers are going to be ones where even if the sufficient condition is true, the necessary condition doesn't necessarily follow. These questions where they give you 5 conditional answer choices tend to take a long time. So a lot of people would take an educated guess. They would look through the answer choices really quickly, take an educated guess as to what the answer is, and then check that one first. And if that one was not the right answer, then look at what you have left and try to take an educated guess, and again try that one, and then so on. And that can work for a lot of people because you really can probably get to the point where your educated guesses are more likely to be right than not. So you can kind of speed up by doing it that way. I'm not going to do it that way because I actually know what the answer is, so it wouldn't make much sense for me to take an educated guess, right? So I'm going to go through one by one, and just to make sure that everybody's following me, I'm going to take each answer choice, I'm going to put it in the drawing, and then show either why it doesn't have to be true, or show why it's the right answer and it does have to be true. Okay, so let's start with A. A says if T and X are added to class 2, V is added to class 3. So what we want to do is try to make it so that we can add T and X to class 2, but not have to add V to class 3, right? So let's try that. T and X to class 2. And now we want to keep V out of class 3. Okay, so we can put V in either class 1 or class 2, but we don't want it to be in class 3. So let's just say that we put V in class 2. Can we do that? Then who would we have left? We have W, Y, and Z. So we need to keep W and Y apart. So let's put the Y here and the W here, and then we can put the Z here. Okay, and there may be other ways you can do it too. So, but all you need to do is to prove to yourself that you can add T and X to class 2 without adding V to class 3. Okay, so there's one way to do it. Let's look at B. If V and W are added to class 1, T is added to class 3. So now they're saying if we put V here and W here, then we have to add T to class 3. So let's try to avoid that by putting T in class 2. That's really our only option. And now who do we have left? We have X, Z, and Y. Okay, so X, Z, and Y. And actually there isn't going to be a big problem here, I don't think, with how we place the X, the Z, and the Y. Actually, let me be careful. The Y can't be in group 3 because it can't be with S. So then this would be, X and Z. X/Z, X/Z. Okay, so this is actually the way that it would have to look. I didn't make any guesses or anything on this one. And if you can't avoid them, it's normally a good practice to just write the X/Z, X/Z. On this one, it's not going to really matter. As long as we can come up with a solution where the sufficient condition is true but the necessary is not, then we know that that's not the answer. So B is not the answer because we can definitely keep T out of class 3 even when we put V and W in class 1. Let's look at C. It says V and W are added to class 1, Z is added to class 3. So this is similar. And we know, this one we actually really don't have to draw. I'm going to draw it, but just based on what we just did, we know that this does not have to be true because while we do have to put the Y here, V and W are added to class 1, T, so, and we want to keep Z out of class 3, so we want to put the Z here, okay? The thing is, we're still left with X and, who else is left? X and T. So this is going to be X/T, X/T. In other words, this one functions almost exactly like the other one, so we could probably have figured it out without drawing it. So the point is that we don't have to put Z in class 3. We have actually 2 other options for who we can put in class 3. All right, so let's take that off the board and look at D. If V and X are added to class 1, W is added to class 3. So we put V and X, and this is, kind of mechanical. You put V and X in class 1, and then you want to keep W out of class 3, so you put W in class 2. Now, can we do this though? This is the problem, right? This one looks like it's the answer because we still have to put the Y down, and we have a problem because the Y cannot go with the W and the Y cannot go with the S. Okay, so in fact, if we put the V and X in class 1, we can't put this W here because then there's nowhere to put the Y. So we actually it does dictate that we put the W in class 3. Okay, so hopefully the way that I was doing this question makes sense. When you come across a must be true question when you're doing process of elimination. If you don't know the answer ahead of time, and this one there was no way for us to know the answer ahead of time because they didn't give us any extra information to go off of, you have to try all the answers. It makes sense to try to take an educated guess and check it in that order rather than the order in which LSAT gives it to you. All right. And then when you're checking your answers, what you want to do, especially when the answer choices are conditional, but no matter what, actually, you want to try to prove that the answer choice is not necessarily true. And when they're conditional, you want to say, okay, I can have the sufficient condition, but not the necessary condition. And that's what we were doing. And we were going along fine with A, B, and C. We were able to say the sufficient condition is true, but the necessary condition is not true until we got to D. And when we did D, we tried to make the sufficient condition true and then avoid the necessary, but we were not able to avoid the necessary. So that's how we know that D is going to be our answer here. All right. That's it for this game. So I will see you in another video.